Good morning, everybody. People are still waking up. Hi, Nikki. How are you this morning? Tez, I'm glad you're awake. All right. Just trying to quickly sort out the YouTube. Can't see my screen, and then we will kick off the session today. All right, found it. The session today. Good morning, everybody. We are here again this morning. Welcome to Krazifizix. And we will be looking at our fourth lesson on number patterns. I said in closing yesterday that we are almost done with 4 weeks of work. When you resume back in January, 4 weeks is already almost completed. So you're staying ahead of everyone. During this holiday season, get past papers now and try to look. So right now you should be doing question 1, 2, and 3. Question 1 is your algebra. Question 2 and 3 are number patterns. Get that sorted in your paper 1 before school opens. You are staying ahead of the whole pack. By the time everybody wakes up, you are far ahead. Awesome. So yesterday we started looking at geometry. Let's summarize what we did yesterday, just to bring everyone up to speed. So we looked at the geometric sequence yesterday. So I'm just quickly going to do a catch up for about 5-7 minutes. Today we just want to deal with so many questions. I just want to deal with questions on geometric, but to bring everyone up to speed, to remind you of the things we did yesterday. All right, here we go. Okay, catch up quickly. A quick catch up. A quick catch up on the geometric. I'm going to be a bit slow so that, because I don't want you to miss anything. All right, we said, what are the properties of a geometric sequence first? Since the sequence, we know we're dealing with T1, T2, T3, and that continues until Tn. All right. Now, we said our T1 will still be A. That would remain. And our Tn in this case would be A times R to the power of n minus 1. Please take note of that. A times R to the power of n minus 1. Okay, that's number 1. Identifying our terms. We spoke about this one having what you call not a difference, rather a common what? Ratio. And ratio means you are dividing. Our common ratio is R, and this is Tn over Tn minus 1. That's the entire formula. That's the accurate formula for the ratio. But if you want then use terms, specific terms, we can then say, oh, it is T2 over T1. It is T3 over T2, on and on like that. Then we spoke about multiple ratio, where we said Tk over Tm would simply be Rk to the power of k minus m. For example, check if I have T10, examiner has given me T10, and they have given me T3. What would I say? This is R to the power what? 7. Why? 10 minus 3 would give me 7. So that's a short form of getting your answer. All right. Tk over, for difference, we said Tk minus Tm. You talk about the difference. Now we're talking about a ratio. And then we brought in a mathematical principle, a basic principle that everyone should remember, that if you are dealing with, if you're looking for R, if it's an even root, talk about your 2, 4, 6, this should be plus or minus. But if you are dealing with an odd, it is just going to be positive. All right, please take note, this one is just positive. Then I taught you something new yesterday, again, algebra, saying if a to the power x is equal to y, then we can find x by saying the log. A is the base, it will go as the base. So I think I used b, but doesn't matter anyway. And b would be there using your log function. We're going to do that again today. Or we can then write as log b over log a. This is something new. It's grade 12, but it's important that you know how to work things out there, where b must be greater than 0 at all times. So this was where we started. Oh, by the way, don't let me forget something here to say, for our geometric, therefore, if T1 is equal to A, what is T2? It is going to be AR. You multiply. What is T3? AR to the power of 2. Your exponent drops by 1. What is T4? AR to the power of 3. What is T99? AR to the power of what? 98. This must be known. What is T44? AR to the power of 43. There's a question I'm looking for. I don't remember where it is, but I'm going to try to create it today. All right, so these were the things we spoke about yesterday. Make sure you have an understanding of this, because today I'm just going to be applying. I'm going to be very, very slow today. I'm just going to be applying everything that we have on this page. Then we talked about a series, which is an addition of our sequence. If you remember, series means you're adding things up. Okay? If I then want to add, what should I then do? Geometric sequence or geometric series, where we said Sn is T1 plus T2 plus T3 up to Tn. Now, this one is a finite because it ends. We said Sn would be equal to A into bracket R to the power n minus 1. The formula would be given where R should not be equal to 1. But then I said we could write it as this as well by using sign change there. Over 1 minus R. Still, R should not be equal to 1. This is the formula that is given on your formula page. And I told you how to prove that formula. I'll go through the proving again quickly. That is the one given on the formula page, but the second one works. And then we spoke about sum to infinity. Sum to infinity, that is S infinity is T1 plus T2, and then it continues. So S infinity is A over 1 minus R. Then I spoke about, before I go to the relationship, S to infinity will converge. Convergence. If R is between -1 and 1, condition. But it will diverge if R is less than -1 or R is greater than 1, using our inequalities. And finally, yesterday we said by mathematical manipulation, Sn can be written as S infinity 1 minus R to the power of n. This was everything that we spoke about yesterday. And obviously, we did our sigma notation. So today, please, I want you to follow closely. I'm going to be applying all of this in the questions that I gave you. I'm going to be very slow because I know most of us are new to this. So please follow through all the activities. I'm going to give you some time. Please do ask questions. Let's walk through together. By the end of this session, in the next 2 hours, we should be done with anything geometric. All right. So we can shoot. Okay, let's look at this one. Like I said, very slowly this morning. Given the following, please make notes of the type of sequence you are given. It's a geometric, so I know I'm talking about what? A ratio. Determine n. If the n term of the sequence is equal to, determine n means number of terms. Okay. What is the formula? Number one, I know the formula is Tn AR to the power n minus 1. I do know my A, but what is my ratio? Ratio is T2 over T1, which is 10 over 30, and that would give me 1 over 3. Oh, that's my ratio. Beautiful. So that's the first thing, and I need us to understand that. Now they've given me a term. Oh, they've given me a term. Okay, what is Tn? Let's see if we can show you what Tn is. What is my A? Remember, A to the R to the power n minus 1. What is my A? First term, 30. What is my ratio? 1 over 3 to the power of what? N minus 1. This is my Tn. But now I am looking for n, then I know my Tn. Oh, let's work through. I hope my slowness is not offending anybody, just to make sure we are all good. Please, and I said, do not do this. 30, 1 over 3, n minus 1. This is wrong. Please, we don't multiply like that. Many learners are going to make that mistake this year. That's an error. We don't multiply like that. What is this equal to? 10 over 729. What should we do? Let us divide both sides by 30. Do you want to help me divide? What are we going to get? So this would be what? The 30 would cancel there. 1 over 3 to the power n minus 1. What would that be? Somebody help me there. 729 times 3 would give us what? You have 1. Confirm for me. That will give us No, 3 times 9, 27. I have 2. 3 times 2 is what? 6, 2, 8, 2187. Confirm? Oh, thank you, Divine. Now, what do we do here? Here we said there are 2 ways. Either you use your shift fact method, turning your 2187 into factors. So you press 2187 equals to shift factor on your calculator. What would that give you? 81 is 456. Talk to me. Is it 3 to the power 6? Somebody talk to me. 2187 equals to shift fact on your calculator. 6 or 7? 3 to the power 7. Beautiful. So we're saying 1 over 3 to the power n minus 1 is 1 over 3 to the power 7. Meanwhile, 1 can be written as 1 to the power 7. Let me go to a fresh page on this. Let's take this to a fresh page. Let's take this to a fresh page, because I want to do the 2 methods. Those that were in yesterday, you'll remember we came across this. Okay, so we said 1 over 3 to the power of n minus 1, 1 over 2187. So we changed this. We said this is 1 over 3 to the power 7. But 1 can be written as 1 to the power of 7. So 1 over 3 to the power n minus 1. Since they have the same exponent, we are going back to laws of exponent. Same base, equate the exponent. What is n therefore? 8. Or somebody else can bring in the advanced way, which you need to learn. 1 over 2187. I'm looking for an exponent variable. If it's an exponent variable, I'll bring in my logs. This one is a base. It must also come here as the base. And I have 1 over 2187. What will this be equal to? You just grab your calculator quickly. Oh, I'm going to block your view there. Forgive me. All right. I'm using the log on the right-hand side, the one with the 2 boxes. Log. What is my denominator? 1 over 3. And what is my main number there? 1 over 2187. Check my answer. My answer, it gives me 7 straight. Oh, so n minus 1 equals to 7, n therefore is 8. Please make sure you learn both methods. Very, very important. And I told you some of you, your teachers will introduce you to something like this. All right, check this again. It is 1 over 2187. I want you to know both of them so that you're not confused. I could say, check this, log 1 over 2187 over log 1 over 3. This one has it has a base, but it's not written. We call it natural base, natural log, where the base is 10. And what will I be using on my calculator? Let me show you this. I'll go there again. Now it's division. I'm using the one that just says log. See, there's no base. The base is 10, but we don't write it. Okay, 1. So please practice these things over and over again. Master them. Check. Again, log. Know the different types of logs that we have. Ideally, we're supposed to teach you all the logs. Log rule. Can you see again? It is 7. Okay, so these are 3 ways. 1 by using your exponent, and then number 2 by using your logs. Let me know if we are okay. Let me know if we are okay with, the mathematical processes. Beautiful. Beautiful. Let me know. All right, thank you. Thank you for all the answers. Thank you, Thurs. Okay. And I think we can then go for the last one. Calculate 30, 10, 10 over 3. Okay, I'm going to rewrite that question quickly for you. It says 30 plus 10 plus, what is it? 10 over 3. Okay, I wanted to check this quickly. What do you notice? It's 3 dots. It's infinite. So this is what? Infinity. Once I see that, sweet. I know I'm using my sum to infinity. You just bring in your formula. A over 1 minus R. What is my A? First term, 30 over 1 minus. What was our ratio? 1 over 3. You put that in a calculator. Please put that in a calculator for me. 30 divided by 2 over 3. That should be about 45. Let's check. Yeah, 45, I think. Somebody help there, confirm. 30 divided by 1 minus that over 3. 45, right? Yes, the infinite. Okay, let me show you a formula page. I think it's important. Let's crop a formula page so that you are used to it. Let's get a formula page. Let me just get my USB and get some resources. Do I have it here? I want us to see the formula page so that it's not something new to us. Okay, I don't have my formula page here, my USB, but let's do this together. I want to show you. Okay, let me create a fresh page, and then we get a formula page together. Let me check if I have a resource file on my system here. I usually do. That's good. Thank you for reminding me. Wow. I think I must have deleted all of this. Yes. Okay, but no problem. Not a trend smash. Not a trend smash at all. Just going to get one paper quickly. Any paper will do. Any paper will do. So that we see. Come on. All right. I like to use Google. It's going to be easier for us. Let's get the formula page. So we're just going to look for any maths paper, right? Let's go to education. Or how am I doing that? Okay. Education.gov.za. You can look at any site. You can look at EC. That's another one that is very, very common. Okay, just to get any question paper for us to work with and see. Why is Yahoo doing this to me? Accept all. I don't need all of this. Just going to download a quick paper. There are so many sites you're going to get used to. All right, grade 12. We look for any paper. May, June. All right, beautiful. 2023, a recent paper. Great. Let's look for mathematics. Okay, accounting, blah, 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 blah. Scrolling down to where we have math. Oh, here we are. No, math literacy. Okay, here's a maths paper. So the same formula page that you're going to have in maths paper 1 is the same one for maths paper 2. So I'm going to the last. Here we go. Beautiful. And here is your formula page. So let's crop it. That will be your number pattern section. Okay, that's your formula page there. I hope you see the formula page now, right? Good. That's your formula page. Let's just label. What is this? This is going to be your arithmetic. What is this? Geometric. What is this? Sum of arithmetic. What is this one? Sum of geometric. What is this? Sum to infinity. And what is this? The rule of convergence. All right, are we okay now, guys? So let's get familiar. That's the formula page. That makes sense? That is your formula page. So let's get used to it. You'll be given from day 1. Let's know what each formula stands for, where the formulas are. So don't be afraid of the formula. We must just know what formula so you are given. Remember, we also should learn the proofs, right? Lovely. Okay, so can we move on to the next question now? We're just doing questions today, close to 10 or 12 questions for us to get familiar. There we go. Look at this one. Number 1, prove that A plus AR, I want us to walk through this together. So I'm going to create quite a number of these pages. Okay, here's our first question for today. 6 marks. I told you what to do in case you missed it yesterday and you forgot or you got lost. Don't cram it. For this particular one, what do you do? Okay. Why is my board running? Okay. Oof. Must give me a heart attack. All right. I told you for this one, start by writing the answer down. What is my SN? SN is A 1 minus R to the power N over 1 minus R. What do? Work back upwards. So what are you doing? I would cross multiply, right? So if you cross multiply, what do you get? SN 1 minus R. Just take it step by step. What do? Expand. SN times 1. SN times R will be what? RSN. A times 1, A minus what? AR to the power N. Now break up your formulas. You usually start with SN and then you move to what? RSN. What is SN? Sum of term 1, A, term 2, AR, term 3, AR squared, and that continues until the last term, AR to the power N minus 1. And that gives you your first equation. Now you're saying RSN, multiplying everything by R. AR. AR times A, AR squared, AR cubed. So the last one, if you multiply that, you have ARN. Equation what? 2. Now, do you notice we said SN minus RSN? Which one is SN? Equation 1. Which one is RSN? Equation 2. You are done. 6 marks. You're not cramming anything. You've just been smart, working from down and going back up. Did that make sense to you? Sum is the addition. First, second, third. You're not cramming anything. You're actually praying for this to come out because you know you are going to just get the math very, very promptly and very quickly. We're good, right, guys? So whether they want you to prove these and just put the condition there, R should not be equal to 1 because it then becomes undefined. Start from the bottom and work up. Okay, so this is done. Done, done, done. No sweat, no qualms. We did this yesterday. Okay, let's move on to the next one. 5.2. Let's do 5.2 together. This is all I want to do today, just questions, you know. Okay, 2 marks and 3 marks. Let's just put it there. First one is 2 marks. Okay, let's see. Given the geometric series, explain why the series would converge. Why will the series converge? Remember, convergence, what is the rule? R must be between -1 and 1. So all I need to do is to look for R. What is my R? T2 over T1. 5 over 15. Oh yes, it will converge. Why? Our R is between, so it will explain why it will converge. R lies between -1 and 1. Does that make sense? Because you're saying 1 over 3 lies between that. We are done. So make sure you write the rule and write your answer just like that. Number 2, what are we looking for? Number 2, it says n equals to 1. Oh, check that. 5. Please, I want to beg you, examiners are very cheeky with this thing. They are very, very cheeky. Already, I know this one means sum to infinity. What is my formula? Let's write the formula to see what we need. Oh, so I must get A and I must get my R. How do I get A? I'm starting from position number 1. Oh, so anywhere I see n, I should put 1. What would that give me? That should actually give me 15. What about R? R is T2 over T1. Oh, so let's go get our T2. How do you get T2? So it's 1, 2. So I need my n to be 2. And I know this is 15. If you put that 3 to the power 0 is 1, 5 over 15. Oh, so I'm done. Now I can talk about my S to infinity. What is that? S infinity is 15 over 1 minus, what is my R? 1 over 3. Put that in a calculator. You have 15 times 3 over 2. 45 divided by 22,5. Am I still breaking, Penuela? It's network when this thing happens. Am I fine now? Can you hear me clearly?
Yes, I can hear you now.
Okay. What's our answer to this? Somebody, a calculator? 15 times 345 over 2. Yeah, 22,5. Now, is that what you have? Thank you, Divine. How are you this morning?
I'm good, and you, sir?
I'm very, very well. Thank
That's
you.
great.
That's great, ne? Great. Is that Nuran there? Nuran, is that you? Siziwe, good morning. How are you too? Guys, are we okay with this? Are you okay with the pace? I want to make sure I'm slow. I want you to get this well understood, get the process, understand it, and then fire on for any question. Okay. We're good, right, Nuran? We okay? Siziwe, are we okay as well? Taslima? Can I just get a response from everyone that is in the house? Let's make sure everyone is okay. Beautiful, beautiful. There's no need to rush, you know. We get the principles correct. It just gives us a lot of confidence. All right, 5.3. Let's see what to do with 5.3. All right, the sum of the first n terms of a sequence is given by that. Don't forget, we spoke about relationship between Sn, all right, and Tn. N plus 2 minus 4. Number one, determine the sum of the first 24. Simple. We just put our 24 there. 24 plus 2 minus 4. You put that in a calculator and we're done. It's going to be quite a big number, I think. So we're saying 2 to the power 26 minus 4. Yep. 6710860. 6710. $8,860. Are we okay with that, everybody? Are we okay with that? That we do the relationship when we're doing the relationship. Determine the 24th term. Remember, we said Tn is what? Sn minus Sn minus 1. If you guys remember that. All right. So T24 will be S24 minus S23. Let's look for S23 quickly. What is that? 223 plus 2 minus 4. This is just the easiest way to accommodate everybody. 2 to the power 23 plus 2 is 25 minus 4. All right, that will give us what? 335544. Oh, I love this number. 3335428. 35428, which means my T24 therefore would be what? 6718. All right, somebody's giving me an answer. I'm going to wait for you to give me the answer here. And you see, you don't want to complicate your work. You want to take it step by step, make it neat so that you can follow through what you're doing. Give me an answer. Give me an answer. Divine, 33554432. Is that your answer? Final answer.
Yes, sir.
Is that what you got when you did this by yourself? Or now?
No, when I did it by myself.
You did it exactly like this?
Yep.
Yep. 554432. Beautiful. And you see, it's quite easy to get the marks in maths. Maths is not difficult like people say it is. Just follow your lessons, understand the principles, remember them. And you can only remember by consistent practice. Prove that the nth term, okay. Guys, when I see this, I will ask myself, what is Tn? Okay. What are the things that I need? There are two ways, but I want to go through the simplest way. I need my A and my R. That's all I need. Okay. Let's see. I need my A and my R. Okay, let's find A. A is the first term. I told you T1 is the same as S1. Oh, so I can just put that there. 1 plus 2 minus 3. I think this is simple. 2 to the power 3. No, minus 4. 2 to the power 3 is 8. And 8 minus 4. This should give you 4. Done. All right. Can I get my T2 so that I can get my R? What is T2? T2 is S2 minus S1. See, I don't want to do shortcuts. I want us to do basic principles. So can I get S2? Yes, I can. You remember how to get S2? We substitute. 2 plus 2 there, minus 4. So we have 2 to the power 4 minus what? 8. What would that give us? That's 16. 2 to the power 4 is 16 minus 4, 12, right? So what is T2? 12 minus 4, S2 minus S1. This gives me my R, T2 over T1, 8 over 4. So what is my Tn? A, what is my A? 4. What is my R? 2. N minus 1. But it's not looking like what I want. Wait, I can rewrite my 4. So examiner wants you to do a bit of maths now. Let's squeeze it here. I can rewrite my 4 into exponent. Let's squeeze it here. So Tn, my 4 can be as 2 to the power 2, 2 to the power n minus 1. Oh, if I am multiplying, what do? I keep the base and add the exponent. What is 2 minus positive 1? Did that make sense to you people? So I just want to go basic, simple, understanding the principle. You know, you don't solve a difficult problem with difficult solutions. It requires very simple. Let me know if we are okay. YouTube, Google Meet, talk to me. Are we okay? Did it make sense? Step by step. All right, let's quickly finish writing. Let's write that solution. So take all of these things that were done this in 1, 2, 3, 4, and that will be 4 weeks of work completed. All right, I guess I can move. Let's see what's next. We're done with the whole of this page. All questions done and dealt with. Beautiful. Let's look at the next one. Oh, we started this yesterday, right? Beautiful. And I led you on to what the examiner means. Given the geometric sequence that determine the value of x for which the series converges. What is the rule of convergence? The rule of convergence. R must be between that. But what is my R? T2 over T1. That's my T2 and that's my T1. So you have x minus 2, difference of 2 squares. Our R is x plus 2. So what do? We go back to our rule. Anywhere we see R, we put what the equation of R is, or expression. And what did we do? We moved the 2, grade 8. You remember all of this. Is it? No, grade 10. Subtract 2, subtract 2, subtract 2. So x must be that. With that. If x equals to -3/2, remember we're just marking the work from yesterday, right? Calculate the sum to infinity. Okay, so we go with 2.2.2. We're just marking yesterday's work, hence the pace. But I'm still slow, I think, to make sure everybody catches up. Okay, let's see. If x equals to -3/2, calculate the sum to infinity. Start by writing what your formula is, so that you know what you need. I need my a and I need my r. Oh, what is a? It's the first term. And the examiner has given me what my x is. So what is your answer? What is your answer here? -7/2, I think. Somebody confirm that? -7/2. Confirm. Use fractions. You know, it's always a lot easier. Let me know if that is correct. Just waiting for your response. Is it a slow network today? All right, thank you, Divine. What else do I need? I need R. Remember what our R is? We did it a while ago, so there's no need to do it again. T2/T1, we got x plus 2. What is our x? -3/2 plus 2. That is 4 minus 3, and that will give us half. So what is sum to infinity? What is our a? -7/2, 1 minus half. What will that give us? 1 minus half is half. So my answer should be -7. Answer should be -7. Okay, so negative, you have 7/2. Some of us don't know how to do that in calculator, so let's show us. Then 1 minus 1/2. Yeah, -7. Guys, are we okay? I'm just following the same principles I've taught you, not doing so much. Taking whatever principle that I have learned and just throwing it where I'm supposed to throw it. That's all. So please go back to the content, the theory. You know, even the summary this morning just says it all. Okay. Next one. The bonsai. Application. Chris bought a bonsai, a miniature tree, at a nursery. When he bought the tree, okay, a few things are covered there. Let me do this. Let me do this because I want us to read the whole statement. All right. We're going to do it this way. I'm just going to drag this down a little bit. All right. Okay. When he bought the tree, its height was 130 millimeters. Thereafter, the height of the tree increased as shown below. So when he bought it at 130. During the first year, it grew by 100 millimeters. Second year by 70. Third year by 49. Chris noted that the sequence of the height increases, namely 100, 70, 49, was geometric. Wow, okay. During which year will the height of the tree increase by approximately 11,76? Oh, it's geometric. Beautiful. If it's geometric, let's write the terms. 100. Let's write the sequence. 100, 70, 49. Okay. 100, 70, 49. And the examiner says, during which year will it become 11,76? All right. Let's put it here, 11,76. We don't know. Basically, we're looking for the term. Let's start by saying, since it's geometric, what is my R? T2 over T1, 70 over 100, 7 over 10. What is our formula? Tn, A R to the power n minus 1. What is our Tn? 100, 7 over 10. Please remember, don't cancel the 10 and the 100. What are we looking for? 11,76. Okay, so 100, 7 over 10, 11,76. What do we do, my dear learners? Let us divide by 100. So if you like, you can change this 0,7, or you can leave it as a fraction. Doesn't matter. What will this give you? 0,1176. I think this one we can simply bring in our logs. So what is n minus 1? So watch what I'm going to do. What is my base? 7 over 10. So please put a note for yourself. When do I use logs? Just put a note there. When the variable to be calculated is an exponent. So if the variable I'm looking for is an exponent, I'll use logs. Again, let's write the rule. A to the power x equals to b. What is x? Log, the a goes to the base and the b goes there. Or the numerator and the denominator. Just make sure you know, because I don't know which one your teacher, people have different preferences, so you have an idea of what is going on. Okay. Anybody wants to give me n? Let's confirm. Anybody wants to give me n? Use your calculator. I want you to confirm so that we know how to use it. We'll look into more rules of logs when we do functions. Yes, anybody? What is the value of n? Yes, talk to me, Noran. What's your answer? Divine Terms, pen, C's way. N equals to 7. Do we agree? Can I get a confirmation? I could also use my exponent, all right? I could also use my exponent. So what do we have? Log of 0.7, and 0.1176. Okay, beautiful. N minus 1 equals to 6. Thank you, Nuran. Beautiful. Well done. N equals to 7. Thank you. Oh, thank you, Sizwe. Your answer just came in. Beautiful. Guys, we okay there? Now we know what to do with maths. Can I get your response? Can I get a feedback? Thumbs up, thumbs down? You're lost? I'll be waiting for that. I know the network is a bit kind of weak. The strength is not so. So answers are delayed. Responses are also delayed. So let me just hold on a little bit to make sure we are all good. Okay, looks like everyone is okay. I've gotten a lot of feedbacks. Okay, so that's the first question. 7 years. They said during which year? So it's the 7th year. All right, let's put the answer nicely. The 7th year. Now let's move on. Chris plot a graph. Don't worry, you're not plotting any graph. Let me go to where we have all the question. Chris plots a graph to represent the height n of the tree in n years. Please read the question carefully. Chris plots a graph to represent the height n. Remember, this is an exponential graph, by the way. In n years after you bought the tree, calculate the formula weight of hn. What are we talking about? The height of the tree. Okay, since the tree grows geometrically, what are we looking for? Height. I'll tell you where you're likely to forget something. Height after what? N years. So we have, this is the growth. $49 and TN. But these just represent what? Growth, not the height. We bought the tree at 300. So look at this. For the first year, what's going to be the height of the tree? It is 300 plus 100. Does that make sense? The original height was 300. It grew by 100. So it's now 400. Second year, what will it be? 300. It grew 100 for the first year. I hope you're seeing that. The third year, what happens? The original height is that. Oh. So basically, we are adding. What will the height be after n years? Do you notice that all of this? Okay, let me do this. What is this? This is what? Sum. Because it's 100, then it grew 70. Ah, nice. So the height, I'm going to pause a little bit here, will be 300 plus Sn. What's our formula? What would that be? So this is application and interpretation. What is A? 100. What is our ratio? 7/10. All right. Let's use, since we have two brackets, A, R, N. The minus one is a whole number over I don't know if that makes sense as a formula. Does that make sense? Let me know if that makes sense. All right, just give me your responses quickly. So guys, interpretation is very, very important. We can simplify this further if you want us to simplify. All right, 300 plus. Now, you can just take your calculator and simplify the, don't touch the brackets. All right, so I would say what, 100 divided by 7 over 10 minus 1. Okay, so you can leave it like that, or you can take it further, minus 1,000 over 3. All right, it affects that, minus 1,000 over 3, but my bracket still remains 7 over 10 to the power of n minus 1. Just to make our answer look mathematical. Someone saying, why are we subtracting? Don't worry. The bracket is going to be a negative, which will change that into a... Let's try it. Let's try it. If my n, for the first year, let's just prove. Let's try proving. Let's try to check if we are correct. First year, we're saying 300. Let's see if we're correct. Minus 1,000 over 3. 7 over 10 to the power of 1, because it's the first year, right? Let's get a calculator, because I love us to see that whether we're correct or wrong. Minus 1,000 over 3, we open 2 brackets. We have 7 over 10, exponent of 1, if you want to put it, doesn't matter, minus 1, close the bracket. My answer should be 400. Check that. My answer should be 400. Why? 300 plus 100. The second year, my answer should be 470. I want to try it. 470. This one becomes to the power of 2. 470. Do you know how I got the 70? 470? 300 plus 100 plus 70. 470. If I add the third year, which is 49, that should be 49. 4 plus 11. Okay, that should be 519. Let's check. For the third year. Ooh, what did I just do? For the third year, to the power of 3. Please, I hope it makes sense. That's the height of the 3. So you need to interpret well. The height of the tree plus the growth. The height was 300. First year, it grew by 100, which makes it 4. Next by 70, 470. Then we keep adding. Let me know if my explanation makes sense to you. Please, guys, before you start doing any question, interpret the question first. It is of importance that we interpret first. Okay. So you see, we got that as 400, which is correct as my first answer, first year. I don't know if we are still writing or you were able to pen down everything. Those of you on YouTube, let me know if everything is going well. No complications, just interpretation. What height will the tree eventually? What is that? Because we don't know how many years the tree is going to be. Eventually, it's infinity. Oh, so examiner is saying sum to infinity. But since they are talking about height, what would it be? Height eventually will be what? 300 plus sum to infinity. A over 1 minus R. First growth, 1 minus 7 over 10. What will the height be? Let's get a calculator there. You have 3 over 10. What will the height be eventually? (633,33). It will not grow beyond that. Millimeters. Let me know if that makes sense and we're good. Application of what we have been taught. So examiners are not going to come directly, you know. They're going to try to play around and play around with information, but the application is what matters. So please read, understand, and then apply. Read, understand, and apply. Let's see if there's anyone who needs, who has a question. Let me see. Can I get all your responses? I'm going to try to keep an eye on every participant. Let's see. Just give me a thumbs up if you're okay. Okay, I'm checking. There we go. Okay. Divine, did I see any response from you? All right, so that's the question there. Divine, let me know. I'm just keeping my eye. I don't think I saw anything from you. We're good. Look at this one. Consider the sequence: half, 4, 1 over 4, 7, 1 over 8, 10. If the pattern continues in the same way, write down the next two terms. What do you think? Let's see. Share your answers with me here. I want to see this one. Share your answers with me quickly on this one. If the pattern continues that way, what do you need to notice? There's a fraction, there's a whole number. Kind of something that, you know, we must be able to pick what's going on. Share your answer. I'm interested in your answer. The next two terms. What do you observe? What do you observe? Any observation? You can talk to me if you want to unmute yourself. Let's see. Who wants to talk to me? Nuran, do you want to say something to me? How would you interpret this question? Penella, how would you interpret? Divine? Sisizwe? Tess? Okay, I've got a long love letter here. Oh, okay, all right, Divine. Okay, cool, you'll catch up. Awesome. How would you do this? How would you do this? I don't want to keep you long this morning. Just 2 hours up to 10, just to solve questions. Now, if you look at this, what do you notice? If I look at this, I'm seeing if I multiply this by half, I'll get that. Multiply by half, I'll get that. But if you look at the 4, if I add 3, I'll get 7. If I add 3, I'll get 10. Oh, so I should add 3 again, and that will give me what? 13. But this one, 1/2 times 1/2, that's geometric. 1/4. 1/4 times 1/2, 1/8. If I continue, 1/what? 16. So it is a combination of arithmetic and geometric. I don't know if you see that. So 1.1.1, next 2 terms, 1/16, that's the geo part, and 13. 1.1.2, calculate the sum. Look, if we split it, 1/2, 1/4, 1/8, geo, 4, 7, 10, arithmetic. We are adding. Don't you see that we can then say S50 will be sum of, since there are 50 terms, 50 is an even number. You need to be careful with this one. And each forms a pair. It means we have 25 geometric, 25 geo, plus 25 arithmetic. I don't know if that makes sense. 25 geometric and 25 what? Arithmetic. That gives me my total because they are 2 different. All right, what is the formula for geo? R to the power n minus 1 over r minus 1. What is the one for this? We can use n over 2, 2a plus n minus 1d. And I think from here, it's just a matter of what? Substitution. For the geometric, what's our a? 1/2. All right, what is the ratio? 1/4 divided by 1/2, which would give you 1/2. But how many terms are there? 25 minus 1 over 1/2 minus 1 plus. Let's look at the arithmetic. How many terms are there? 25 arithmetic terms. What is our first term? 4 plus 24 multiplied by, what is the d? My difference is what? 3. I don't know if that makes sense. Please respond. Let me know if that makes sense. My explanation, let me know if that makes sense. There are 25 arithmetic and 25 geometric. Beautiful. So we're doing them separately, but I just combined. All right. So what do we have? A half, 0.5. Another bracket, 0.5 to the power of, I'm lazy, to the power of 25. Please, let's type correctly. Minus 1 over a half is 0.5 minus 1. That gives me that. Plus, what do I have? 25 over 2. 2a, 2 times 4, which is 8, plus 24 times 3. 1001. Beautiful. And that's why it's 7 marks. Beautiful 7 marks. Your ability to see that it's a geometric and an arithmetic. Ability to see the geo and the arithmetic. Are we okay? Are we okay? Guys, it's all about now exposure. How do examiners ask questions? How do we apply what we've learned? That's all that is now, that's what's going to matter now. Content has been done. Can I apply what I have been taught? Can I relate what I've been taught to the question that now lies in front of me? Okay, we can take a screenshot of this if you're, to get both the question and the answer. 25. Please take note if it is that okay? Odd number means the last one is missing now, right? So I'm going to have what? Which one is the first one? I'm going to have 25 geo and 24 arithmetic. The arithmetic is the one at the end. So if I say 49, I have removed the last term, and the last term is an arithmetic, so it's one less. Take note of that. It is one less. So if I say 49 times, it'd be 25 geo and 24 arithmetic. So these are the little things they want to slap us with left and right, but let's get them in our sessions. For a lot of you that will take these sessions to heart, next year you would find this very, very easy. And you use these lessons again to revise just before you write. Any test, any activity, just come to the activity session and walk through. Okay, let's see. What do we have? I think this was where I gave you up to stop. Now let's look at this one. We are going to interpret together. It's a long statement. Please take your time. Read through first. The first two terms of a geometric sequence and an arithmetic sequence are the same. Let's stop. The first two terms of a geometric sequence, okay, so we have geo and arithmetic. They are telling us that T1 here is the same as T1 there. T2 here is the same as T2 there. Okay, can you see my interpret? Don't run, don't run. The first term is 12. Oh, beautiful. Now we have a value. This one is also 12. The sum of the first three terms of the geometric is 3 more. Oh, wait. The sum of the first three terms of the geometric, T1 of the geo, T2 geo, T3, that is equal to 3 more than 3 plus the sum of the first three terms of the geo, 3 more than the sum of the arithmetic. Can you see? I've interpreted. I am done with the question completely. Find the two possible values of R. Beautiful. Let's do this on a different page. Okay. So what is my geo? It is AR squared. It is 12R squared. What is my arithmetic? It is A plus D. That's what we know. The first two terms. But my A is what? 12, right? Okay. Let me do the third one because they gave us something about the third. But what is this? 12 plus D, 12 plus 2D. Then they said the first three terms of the geo is 3 more than that of the arithmetic. First, second, and third. Okay, let's interpret 12 plus 12R plus 12R squared, 3 plus 12 plus 12 plus D. Once I've done this, all right, so this is an equation, but we're told that the first two are equal. Oh, so can I then say that 12R, but 12R, okay, let me say, but T2 geo is the same as T2 arithmetic. What is the second term of the geo? 12R is the same as that 12 plus D. Oh, so we can, whichever way you want to do it, it's now two equations. We can then substitute, you know. We can then walk through substitution. There we go. So what is D? 12R. Anywhere I see D, can we substitute? Okay, let's go. So what we have? I've got 12 plus 12R plus 12R squared, 3 plus 12 plus 12 plus, what is my D? 12R minus 12, right? So instead of writing that D, 12R minus 12 plus A, which is 12, plus 2D, 12R. Do you notice the only thing I have left is my R? I don't know if what I've done makes sense. This is 3 plus A plus D. It's a plus. A plus 2D. All right, are we okay there? First term, second, let me just make sure it's correct. 3, my first term A, my second, 12 plus, but my D, 12R minus 12, my first A. All right, let's simplify. It's now done, math is done. Let's please, the way you write also matters. What is this? 12 plus 12R plus 12R squared. Okay, 3 plus 12, 15. 15. Okay, this 12 would cancel this 12. Okay, let's do 15. This 12 would cancel that 12. I have 12R. I have 12 plus 24R minus 24. Okay, you just simplify now, guys. It's now baby maths, but your simplification matters. Okay, look at this 12R and this 12R. Depending on how you want to do it, that one goes. All right, so what do I have left? This 12 positive, this 12. If I move this 12 over, it goes away. So what do I have left? 12R squared minus 24R. Okay, what is 15 minus 24? 9. Yep. Which is a negative on this side, goes over, it becomes a positive. Now you can solve. You can use your quadratic. R equals to minus B plus or minus, if you don't know how to factorize. But I don't want to use this. Let's factorize. Let's factorize. Let's factorize together. Very important. Let's divide by 3. 4R squared minus, we're dividing by what? By 3. 24 would be what? 8. Okay. Those of you that have seen some different methods, this is what we do. 4R squared minus 8R plus 3. We multiply this and that. All right. And that will give us what? R squared minus 8R plus 24. Now we factorize. 24 would be what? And I want 8. What is 24? That will give me 8. 24 is 12 and 2. That's 10. Yeah, 6 and 4. Please, let's make sure we got all the maths right, because it's going to affect our substitution. 6 and 4, 12 and 2. What else? 24 and 1. Okay. Should it give us a decimal? I don't know. Let's try to recheck our steps quickly, everybody. Just to make sure we are okay. AR squared. T1, T2, T3 is 3 more than A plus D, 12 plus 12R minus 12. That's fine with us. All right, because our D is 12R minus 12 plus A plus 2D. A plus 2D. Okay, that's fine. Let's make sure we are on the same page. What did we do? We left this like that, and then we simplify this by saying 3 plus 12 to give us 15. This 12 took out that 12, left us with that. We brought the 12 in. We said 2 times 12, 24 minus 24. That's perfect. We said 12 plus 12R. We'll take out this 12 plus 12R. We're good. 12R squared. We have 15. Brought this 24 over. All right. 15 minus 24 will give us negative 9, which we brought over here to give us that. Awesome. Okay, so 12R. Okay, we're good. We've done nothing wrong. 12R minus 24R plus 9. We divided by what? By 3. 12 divided by 3 will give us 4. 24 divided by 3 would give us 8. 8 times 3, 24. All right, so we're good. We are good. Trying to factorize for 4 times 3. And you guys kept quiet. 4 times 3 is not 24. 4 times 3 is 12. All right. I think my network is a bit slow this morning. I don't know what's going on. Okay, 4 times 3 is 12. Okay. All right, so what are the factors of 12? 6 and 2. Good. Now, we multiplied by 4. Some of you know this method. What do we then do? We divide by what? 4. So R minus, simplify that. 3 over 2. And R minus half. What do? We move the denominator here. It gives us 2R minus 3. 2R minus 1. Yes, this looks correct. So what is R? 3 over 2, or R equals to what? Half. That's why the examiner says possible values. Let me know if it makes sense. Possible values. Possible values. Please read the English and interpret correctly. If you cannot factorize, which you must learn, please use your quadratic. Let's confirm if we're to use quadratic. So our B is negative 8 plus or minus square root of B squared, negative 8 squared minus 4. What's our A? Our A is 4. And what is our C? Our C is 3 over what? 2A. Check. 3 over 2. And if I change that to a negative, half. Are we okay, guys? Please break down the English into small steps of maths, please. The sum, change it into addition. 1 plus 2 plus 3. Use mathematical steps. Remove the maths from the English and you'll be okay. Remove the maths from the English and you will be okay. Are we all good? Okay, let's look at 3 more questions for this morning. Like I said, it's just activities. Yes. Penuela, talk to me. Yes, your hand is raised.
Sir, may you please go to the previous slide so that I can take a screenshot?
Okay. Of the question. You see, determine
Yes.
2 possible values. And we got 2 possible values. Sweet. You got it right? Okay, look at this one. 20 water tanks are decreasing in size such that the volume of each tank is half the volume of the previous. The first tank is empty, but the other 19 tanks full of water. They said they are decreasing such that it's half of each other. Okay. Will it be possible for the first water tank? Okay, let's call this the first water tank. First water tank. Second, third, fourth, and like that. Will it be possible for the first water tank to hold the water from the other 19? Okay. So we have 19. Question is saying, if we pour water from the second to the last, and we decide to pour everything in the first, will it be okay? We don't know. Wait, if I pour the second in, pour the third, pour the fourth, what am I doing? I'm actually adding. I don't know if that makes sense. I am adding. Oh, so let's find the sum of the 19. 20 water tanks are decreasing in size such that the volume, okay, if this one is V, volume here is V. What is the volume of the second one? It's half V over 2. What is the volume of the third? It's half again, V over 4. Does that make sense? You divide that by 2. What is this? V over 8. So will the 19 fill the first one? Oh, let's go check. All right, 19 tanks now. 19 tanks. What is the first one? V over 2. Next one, V over 4. Okay, we're going to add because we are pouring the water. 19 tanks. Since we're adding, Sn will be equal to what? A r to the power n minus 1 over what? Let's see. What is my A? First time, we said V over 2. Use a double bracket because my ratio is half. There are 19 of them over 1 over 2. Let's see. Don't worry about the V over 2. Let's get a calculator. All right, I'll give you time to write. Let me drag this to the right-hand side so I don't block your view. We are looking for the sum of the 19, S19. If we add all of that together, what are we going to get? So I wanted to see application of questions here. Don't worry about the V over 2, just leave that. What do I have? 1 over 2 to the power of 19 minus 1. We close the bracket over what? Half minus 1. Okay, what's going on? What did I leave? Oh, I opened a bracket and I didn't close it. Or I closed and I didn't open it. 1,999. All right, it's approximately 2. Okay, 1,99. So this is V over 2. 1,9999, and we can just divide that answer by 2. All right, let's do. I want to divide that answer by 2 to see what my answer would be. I don't want to round off yet. Okay, I hope you saw what I did, right? So I said bracket. Let's put a half outside. 1 over 2. Don't worry about the V. We just multiplied by that, right? And we have a bracket. 1 over 2 to the power of 19 minus 1. And then we have 1 over 2 minus 1. Okay, 0,99999 V. 0.99999 blah 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 V. Here's the question. Look at the question again. Would it be possible for the first tank to hold the water from the other 19 tanks? Yes, it will be possible. So we need to answer that. Yes, it will be possible. Do you understand why I'm saying it will be possible? Let me know. Because the first tank is V. My answer is 0.99 V. So it will just be possible. Fill it almost to the brink. Make sense, everybody? Makes sense. So please, question interpretation is very key. Let's take about 3 more or 2. Give you a moment to write. Give you a moment to write, and we'll see what's ahead of us in the next question. Quickly, 30 seconds. Let me know if you're done. Give me a thumbs up once you're done writing. All right, we're good. We're good, good, good. Let's look at the next one. Just 2 or 3 more. No. Okay, this is 2 questions. Let's break it down so we have space to write. Space to write. The first 2 terms of an infinite geometric series are 8 and 8/√2. Proof without the use of a calculator. Oops. That is sum to infinity. Okay, great. What is our sum to infinity? Do I know my A? Yes, my A is 8. Question is, what is R? T2 over T1. What is my T2? 8/√2 divided by 8. What would that be? 8. Remember, no calculators, so we must show all our steps. Okay, and that would be 1/√2. All right, let's see what the examiner is all about. Sum to infinity, therefore. What is A? 8 over 1 minus 1/√2. Okay, this is conjugate, if you remember how to do your conjugate. So this is going to be S infinity 1 minus 1/√2, grade 11, conjugate. We say 1 plus 1/√2, 1 plus, we change the sign, if you remember, conjugate. All right, let's see. Are we going to get what they want? Or, okay, we can do it like this. It's fine. Let's work it out. This is 8 1 plus 1 over root 2. Now, this is difference of two squares. 1 times 1 will be 1, minus 1 over root 2 times 1 over root 2 will be 1 over 2. That you can quickly, secretly use your calculator, but you must know. Let's expand. What do we have? 8 plus, okay, we need to get rid of this. Okay, no, it's fine. What is 1 minus half? That is half. And what does this mean? 8 plus 8 over root 2. We can split this. Wait, they said 16. I don't see my 8 root 2 coming out. Divided by half. This is giving me 16 plus 16 root 2. Okay, we need to go back and check. This is times 2 over 1. This is giving me 16 plus 16 root 2. Let's check again where we have a possible error. All right, T2 over T1. Let's check for a possible error. T2 over T1, 8 root 2 times 1 over 8. That cancels. That leaves me with 1 over root 2. Substituting 8 minus 1 over root 2, we said we can conjugate, right? Conjugate means you multiply by the opposite, the same thing, but the opposite sign. So 8 times 1 would give me 8. 8 times 1 over root 2 would give me 8 over root 2. 1 minus 1 times 1 would give me 1 half. Okay. Oh, here's my error. Here's my error. I found it. I found my error. So I wrote it as 8 root 2 is 8 over root 2 divided by 1 over 2. 8 plus 8 over root 2, everything multiplied by 2. So if we multiply in, what are we going to get? 16 plus 16 root 2. But I cannot leave, it's not the same. What do I do now? I rationalize, which I could have done from the beginning. Oh, this examiner is very clever, trying to see if you remember how to deal with third. Plus 16 over root 2, we multiply this by root 2 over root 2. So 16 plus 16 root 2. Root 2 times root 2 would give us 2, and 16 divided by, beautiful. Please, this is about conjugate and rationalizing. I don't know if you guys remember, it was done in term 1, grade 11. Let me know if all good. So you rationalize and you find conjugate. You rationalize when you have more than one term. Let me just help you here. What do we mean by rationalizing? A over root of B should be simplified as A over root B times root B over root B if you have one term. If you have two terms, A over 1 minus root B, or don't let me use 1 because it could be any number. Let's say C minus root B will be equal to A over C minus root B. Now you conjugate, you change the sign. And what you must know is root A times root A will give you A. If you check your calculator, root 2 times root 2 would give you 2. Laws of surds. I hope we're good. We have 10 minutes. Please, the way we write, take it step by step. Don't rush. See, when we rush, we make mistakes. So we don't rush. We just take it step by step, step by step, step by step. Okay, we're good. You can take a screenshot. Take a screenshot of that. If you take a screenshot, please send on the group. Thank you. If you got a screenshot, please send it to the group. We're finishing now. There's a lot to be done. It's a Saturday. Okay, 1.2. But you guys have done well, you know, sacrificing whatever it is, your bed, and all of those. Consider, we have the following geometric series is given as that. Okay, it's x equals to phi, da, 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 da. Write this in sigma notation. Beautiful. It's a geometric. How do you write your sigma notation? Step one is to find Tn. What is your R? T2 over T1, right? What's my second term? 15 over 5. Great. So what is Tn? First term 5, 3. Oh, so we can then write the sigma. 5 multiplied by 3 to the power n minus 1. First 20. Done. We are done there. We're done. That makes sense. Simple. Calculate the value of x, which is the sum. Oh, sweet, sweet maths. X will be equal to what? Sn, which is it's a geometric. We just write the formula and use the formula. What is our A? 5. What is that? 3. How many? 20 minus 1 over 3 minus 1. Put that in a calculator and you are done. We are done. 5 into bracket 3 to the power of 20 minus 1 over what? 3 minus 1, which is 2. Ooh, such a big number. Yes, it's possible to have such a big number. All right, 871696. 871696. 1000. Because the numbers are very big, right? Can you see it's diverging? It's becoming bigger. The more you add, the bigger it becomes. The more you add, the bigger it becomes. Are we all good? Let's take one more for the day, one for the road. But you see, the more we do questions, we just see how to apply. Nuran, are you okay there? Okay. No, 16 marks. I don't think this one should be difficult. I did 2.2 yesterday. Okay, let's run through this quickly. The full 16 marks. The full 16. All right, the sum of the is given as Sn is 3n squared plus 2n. Sn, number one, let me write the question. Number one, Sn, 3n squared plus 2n. All right, let's go. What is the first one? Sum of the first 10 terms, easy. 10 times, S10. What will this give you? 100, 320, 320. We are done there. Simple. So that we have done over and over again for you to be able to see and understand what is going on there. Number two. Calculate the first 3 terms, oh beautiful, of the series. First three terms. Nice. S1 is the same as T1 because you are just adding. You can add one term. What's your answer? 3 plus 2, 5. What is S2? It is, no, what is T2? What is T2? It is S2 minus S1. Okay, what is S2? Anywhere we see N, we put a 2 there. Minus S1. Does that make sense? 5. 3 times 4 is 12. 12 plus 4 is what? 16. 16 minus 5, 11. I hope you understand what I did there. What is T3? S3. We've done this, so that's why I'm compressing my workings now. 3 squared plus 2 multiplied by 3. Let me put a bracket here for us to see. This is S2 minus S1. All right? Minus S1. Okay, if I do this, just to show you again. If you put this in a calculator, 3 squared is 9, 3, 27. 27 plus 5 would give us what? 32 minus, you have, what, 16, I think. Yeah, we got 16, 4, 12, 16. What would that give us? 32 minus that would give us what? 16. Great. So we have our T1. Our T1 is 5. T2 is 11. And T3 is 16. Just repeating process now. Repeating process. Or is it 33? What do you mean? 33. 27. Oh, plus 6. 33. So that should be 17. Thank you. Thank you. Beautiful. Oh, I can actually see the pattern. Beautiful. 33. Thank you very much. Shows you're still alive. Okay. Everybody good? Is the given arithmetic or geometric? All right. What do you think? You answer that question. 5, 11, 17. Is it arithmetic or geometric? What do you think? Ah, great. It's arithmetic. You can see there's a common difference of 6 there. That is a giveaway question. Why? Common difference of 6. If they ask you why. Is there number 4? If the last term is 161, calculate the number of terms in the series. If the last is 161, how many numbers are in the series? All right, we know it's arithmetic. What's our formula? dn plus a minus d. I'm sure you remember, right? What is our d? 6n. What is 5 minus 6? Minus 1. So we're saying 6n minus 1 equals to 161. 162 divided by 6. How many 6 do we have in 16? That should be 2. 12, 42, 27. Yeah. There are 27. Can you see how maths can be done without stress? Maths done so easily. Everybody okay? We're still using all the things we learn. Guys, I am done with content. That's what I needed you to see. That we just applied. All right, let's do 2.2. Going to do it on a fresh page, and I'll try to bring the question by itself here. Okay, let me do this. So I can cut it. Don't worry, I'm releasing you just probably after this one. Okay. Ooh, I cut the, it's 130/9. (130/9). I want to write it nicely. Okay. In a convergent geometric series, the sum to infinity is 18. S infinity. And the sum of the first four terms is 130/9. If you remember, we did this yesterday, and I told you the formula for sum to infinity is A/1 minus R. Once I see this, I know therefore my Sn will be what? S infinity 1 minus R to the power n. Makes your life very simple. What is my Sn? 130/9. What is my sum to infinity? 18. And what is my R? 4. We're done with it. 6 marks. Makes life easy. Divide both sides by 18. So what do you have? T/9 times 18. So what are we going to have there? 130/7 to 167, I think. So you said 130/9, just to make sure that we are all seeing that. 65/81. Okay, simplified. What do I do? R to the power 4 would be what? 1 minus 65/81. And what will that give us? What is 81 minus 65? That's 16. So R to the power 4 is 16/81. What do we then do? We find the fourth root, but because it is an even root, I told you about that. 16/81. What is R? Plus or minus? This is 2 to the power 4. There we go. In a convergent, they said it's convergent. So R must be, yeah, both answers would work. It's convergent. R must be between -1 and +1. Both answers would work because it's convergent. Remember, my R must be between, because it's convergent, -1 and 1. As long as it's a fraction, it would work, whether positive or negative. Guys, I don't know if that makes sense. We've done a lot of questions to make you understand and see what's going on. Just applying. There's a question I'm looking for, though, if I see it. Okay, can we do this as the last one? I want this. This is the last one I want to do. Guys, check now any paper. Oh, beautiful one as well. Look for more questions. Oh, okay. All right. No, don't let me do it. Let me stop here. Please take pictures of this. If I call for the next class, then we would be marking this, because I want to revise quadratic with you in one session. You've done it before. We just want to look at it again. But then I'll answer these questions. I'll tell you when. Let's take a picture and please send on the group. 3 questions that I wanted to go fight over. I'm checking to see if the questions are now in. All right, first one in, thank you. Second one, let me make it bigger. Because guys, I've armed you now with information. I want you to use the information. All right. Second one. Second one, I'm just waiting to see it in. Who's sending? All right, thank you. Thank you. And the last one. Oh, wait 1 second. Why did you delete now? Because I've gone through tests. Why are you deleting the? Because we won't have that question now on the group. What happened? All right, number 3. I'll go back to number 2 because, oh, is it there? Oh yeah, it's there. I see. That's why you deleted. Okay, Tess, thank you. The third one. Beautiful. Thank you. All right, so we have those 3 questions. We would start with those 3 questions. When I call for revision of, probably do that next week, just 1 hour, 2 hours, call for the revision of quadratic, which ends 4-week session. We would start by marking this. So this is 4 weeks already covered in our 4 lessons, making it 5 when I do the revision of quadratic. Guys, I hope the sessions have been quite helpful to you. The last one will just be a revision. We just do questions, questions, questions. Some of you have misconceptions from grade 11. We need to correct that and move on to our next topic, which is functions. All right, guys, this is it. This is Krazifizix signing out again. Thank you for joining us, and we hope you enjoyed. I enjoyed myself in dealing with those questions. Remember, the principles remain the same. All you need to do is to break down the question and simplify it using simple principles. Interpret first, then apply your principles. Have a lovely, lovely day. Goodbye, everybody. Bye. Bye, Terence. Bye, Pan. We may log out now.